Good day, fellow. Setsu is back. Today I'm going to do with you the new concept, which is of chemical bonding. See, chemical bonding. Let me just define to you the term chemical bonding. It's so simple. It is a force that holds atoms together. That's a simple definition I can give of the chemical bond. Then now we have three of those. We have an ionic bond. We also have a covalent bond together with the metallic bond. See? Then, as a learner, you must know that as for ionic, it takes place between metal plus non-metal mostly. Then for covalent, non-metal together with non-metal together with non-metal. Then as for metallic, we have metals plus metal. See? Then yeah, but for the sake of today, let me consider firstly an ionic bond. Then by definition, it's just the transfer of electrons from metal to non-metal. See? That's a simple definition of what of ionic bonding. Then now, if I can even continue with this topic, let me touch on valence electron. Do you still remember the definition of valence electron? Let me remind you. Are those electrons in outermost energy level? You see, are those electrons in outermost energy level? As a learner, you must know that all the group 1 elements will have one valence electron, then group 2 valence electron, 3 will have 3 valence electron, group or let me just say group 13, not 3. Group 13 will have 3, then 14 will have 4 valence electron, group 15 will have 5, then 16 6, 17 will have 7, last group noble gas will have 8 valence electron in the outermost energy level. See? Then okay, now don't forget that for ionic bonding, we will always mostly consider the metal together with non-metal. Let me give you an example. Let's say if we have to take a sodium together with uh let's say let's say chlor chloride. Bon? Then we want to add these two. We know that they're going to give us sodium chloride, which is a sorry which is sodium chloride. You see? Then let's go to our periodic table and try to identify where can we see our sodium. You see, the sodium is situated in group 1. Then it's going to have one valence electron in its outermost energy level. Then we also have chlorine there, group 17. It will have 7 valence electron in outermost energy level. Then okay, now I'm going to consider sodium, which is going to have 1 plus chlorine. Let me make X like this. By the way, this is a Lewis dot diagram. For sodium, we also have the Lewis dot of what? Of chloride. Then now, from the definition, we stated clearly that the ionic bonding, it involves what? The transfer of what? The transfer of electrons. From where now? From metal to non-metal. You see? From metal to non-metal. And by the way, almost the the element in group 7 as well as 6 as well as 5 and 4, they have to fulfill an octet rule. Somehow their valence electrons in their outermost energy level altogether, they should be 8. So far I have 7 for chlorine. You see, I have 7 for chlorine. Somehow one of these will move to this one and pair with this one. See, then it's going to be like this. I'm going to have now my chloride as follows. You see, like this, together with that one. You see, then immediately after including that electrons from metal, don't forget to include a negative ion there to indicate that uh, uh, this chlorine has gained what? An extra, sorry, somehow it has gained what? An electron from what? From sodium. You see? Then, as for sodium now, we are going to put a plus sign to indicate that it has lost what? 1 electron. Then this is going to be our ionic bonding. You see, this is how we write a chemical formula of what? Of ionic bonding. You see? Then now, let us consider the situation now. Let me take magnesium together with what? With oxide. See? From our periodic table, we can clearly see again that magnesium, it is situated in group number 2, somehow is going to have 2 valency electrons. Let's say 1, 2. Then let's see oxide. It is situated in group 16. You see a 16 there. It will have a valency of 6. Oh, there. Group 16, valency of 6. Then group 2 will have 2. Then it's going to be 1, 2, 3, 4, 5, 6. You see, we have a metal this side together with non-metal. Always electron, they will move from metal to non-metal. You see, so far I have 1, 2, 3, 4, 5, 6. In order for us to complete our non-metal, you see, we must transfer those 2 electrons to what now? To our our oxygen. You see, to our oxygen, or this O. Then somehow it will receive 1 electron from this one as well as 1 electron from this. At the end of the day, we are going to have something which is like this: X, X. You see, from magnesium, and another one here from magnesium. You see, then how many electrons does this one has received? 2 of them. Then we write -2 to indicate that it has now gained 2 electrons. Then for our magnesium, it has lost 2 electrons. You see, don't forget to indicate what? +2 as well as -2. Here we wrote +1, -1. This one is metal. This side we have what? Non-metal. You see, this is a Lewis dot diagram equation for what? For the ionic bonding. I thank you.